Guys, welcome back to TechDose, and in this video we will look at zero array transformation 2 problem, which is from Leetcode number 3356. Now a prerequisite before watching this is to complete my video on difference array, because the solution will be based on a simulation method using the difference array. Unless you know difference array, you cannot understand the solution, so I will expect that you will watch this video first and complete it. The difference array is used to do range update in the range of L to R with a given value in just order of one time. So this is a very important technique to know. Now I will assume that you have already seen this video. Now let's read the problem statement. In this problem, you are given an integer array nums of length n and a 2D array queries, where queries at I is saying li ri value I. Each queries at I represents the following action on nums: decrement the value at each index in the range of li to ri in nums by at most value I. That means you can choose not to decrement it, or you can decrement it at by maximum of value I value, right? So if the value I is given as 2, then you can choose to decrease the value in the range of li to ri by 0 or 1 or 2, and you can make independent decision for each of the index. Okay, we will see that in the example. The amount by which each value is decremented can be chosen independently for each index. As I mentioned, a zero array is an array with all its element equals to 0. Return the minimum possible non-negative value of k, such that after processing the k queries in sequence, nums becomes a zero array. If no such k exists, then we need to return -1. Now if you look at the first example, in this case the nums which is given is 202, and you can mark the indices as 0, 1, 2. If you look at the first query, it is saying that I can decrease in the range of 0 to 2 by value 1. So you can go from 0 to 2, iterate from 0 to 2 and decrease by a value 1. Your goal is to convert this array into a zero array where all the values are 0. Now if you decrease the first value by 1, which is the max value which is given, it is fine. But can you decrease the 0 by 1 and go to -1? Well, it is not feasible, since I want to convert it to zero array. If it is already 0, then why will I decrement it, right? So I will keep it as it is, and for the last value I will decrement it again by 1. Okay, so this is called independent update, right? Because in the range of L to R, we are actually choosing each of the index how much to decrement, but the maximum value that you can decrement is the given value itself. Okay, now if I had given, like, let's say update 0 to 2 with the value 4, then again on this value, if you go from 0 to 2, then see, even though the value is 4, it wouldn't make sense to decrease 1 by 4 and reach to -3, because our goal is to reach to 0. So I will always take such value by which I can reach to 0 if the value is allowing it. That means if the difference between my value and 0 is actually less than equals to the given value, then I will simply update it to 0, right? Otherwise I will just subtract with the given value. So here I will not update, and here I will update by 0, right? So in this case, if these two were the queries, like 0 to 2 with the value 1 update, and the second query was 0 to 2 with the value 4 update, I don't care what was the third query. Let's say the third query was 113. I would not use it, because even after doing just the first two queries, okay, just the first two queries, 0 to 1 and 0 to 4, I was able to convert this array into a zero array. So I will say that two queries were required, hence the answer is 2. The third query was never needed. Now if you follow this approach and go from L to R for doing the entire update, then you check the constraints out. The array length can be 10 to the power of 5. Okay, the array length can be 10 to the power of 5. So for each of the query, your query length can also be 10 to the power of 5, right? So you might have to go through the entire array in the range of L to R, because L can be 0, R can be 10 to the power 5 minus 1, which is the max size, and you can have maximum of 10 to the power 5 queries as well. So each query will run for 10 to the power 5 times, and if you have 10 to the power 5 queries, your total computations will be 10 to the power of 10, and in such case it is far greater than your 10 to the power 8, and we know that in order to run within 1 second, we have to do computations less than 10 to the power of 8. So this will definitely give you a TLE. So what we need here is to optimize the updates. Okay, we cannot do linear update. Now let's look at a technique which will do range update in order of 1, and that is by using the difference array. I hope you have already watched the video, so I will just give you a quick recap of how to do range update in order of 1. So given an array, I have taken 5 items. I want to do the range update from, let's say, 1 to 3 with the value 2, and I want to do range update from 1 to 4 with the value 3. You can take a positive update, you can take a negative update as well. It's not a problem. Now from this array, I will create a gradient array or the difference array. The first value will always be the same, and after that, the rest of the values will just be relative difference. That means 0 minus 2, which is minus 2, 3 minus 0, which is 3, 1 minus 3, which is minus 2, 4 minus 1, which is 3. Okay. The end value is just a dummy value, and I have appended a 0, because if you want to do range update in the range of L to R with a given value, then we write difference at L plus equals to value and difference at R plus 1 minus equals to value. So if you want to do range update in the range of 1, 2, 3 with 2, then at 1 we have to add this value. So 2 will be added and this will become 0. And at 3 plus 1, that means at index 4, I have to subtract this same value. Okay, so this will become 1. And if you want to do the second update from 1 to 4, add value 3. Then at 1 you add the value 3, and at 4 plus 1, 5, you subtract the value 3. Okay, you subtract the value 3, so this becomes minus 3. So in such case where the end of the index is also in the range, you want to go to R plus 1, and which will be out of bounds. So just to cover up that case, I will be appending an extra dummy in the difference array. Okay, so that I don't have to handle it separately. Now after doing these two updates, the value of the difference array is 2, 3, 3, minus 2, 1, minus 3, right? Now if you have to get the actual array, then you will be just finding the cumulative sum, and at any point of time it will give you the actual array after the range update. So you mention this 2 as it is, add 2 to 3 you will get 5, add 5 to 3 you will get 8, add 8 to minus 2 you will get 6, 6 to 1 you will get 7, and 7 to minus 3 you will be getting 4. But this is a dummy value, you can just ignore this value, whatever is the answer, and your answer will be 2, 5, 8, 6, 7. You can just check it out. You can apply these operations on the actual array 1, 2, 3 with the update 2. So you can make it as 2, you can make it as 5, you can make it as 3. First update done, 1 to 4 with the value 3. You can make it as 5, you can make it as 8, you can make it as 6, and then you can make it as 7. Okay. So 2, 5, 8, 6, 7, 2, 5, 8, 6, 7. So this is correct. Now in this case, all the range update happened in order of 1 time, and in order to retrieve the array finally, we have to parse through the entire array, and that is done in order of n time as well, right? So this is the technique of range update in order of 1, and our solution will be based on this technique. We will be taking the difference array with all zeros, okay, and we will be tracking the current value at any index by maintaining a sum value, which will be starting from 0. In this particular problem, we were first applying all the range updates, and then we were going from left to right by adding the value to get the exact value at any index. But in our case, we will maintain that dynamically. Okay, so if you know this technique, you will understand the dry run. So instead of me speaking a lot about the technique, let's see the dry run, and if you do it in your notebook after having understood difference array, it will be crystal clear for you. Now I have already taken an example of 5 items, and the difference array is of size 6, as you can imagine. The number of queries given are 7 from Q1 to Q7. So this is the queries 2-dimensional array. The strategy here will be to skip all the useless queries. Useless queries means if I have moved in the future, then I don't want to update the past items. This will be understood while doing the dry run. We will be updating only in the useful range. I will show you what is the useful range. That means if I am done with some past items, I don't want to update them again. Which means that if I have already converted an item from X to 0, why would I even touch that item, right? I don't want to touch that item. Then I will be continuously updating an element X until it becomes 0. That means the sum value plus the difference value that I have actually added to it. If it is less than a at I, then we will be continuously applying the queries. Otherwise, if we run out of queries, then we will return -1. That means we could not convert this x to 0. So what we are doing is, instead of decreasing the value from for each of the items to 0, I will be taking a difference array with all the values 0, and I will try to increment all these values in such a way that it matches the array value. That means the first value should match 2, second value 0, the third value 3, fourth value 1, fifth value should be 4, right? That is what my goal will be, to increment the value so that it matches the array value. Fine, because I don't want to update the array since it is in the input, right? Once we have understood the input, let's now do the try run. So what I have to do, I will be looking at the first query. It is saying update in the range of 0 to 3 with a value 1. Now you check it out. At which index are we starting? We are starting at index 0. So from 0 to 3 you have to update with 1. That means you have to decrease the value by 1. Or you can say that if you starting with 0, you need to increase the value by 1 and reach to the array value. So if I have to start from 0 and go till 3, I have to increase the value by 1, means I will be adding a 1 value at 0, and at 3 plus 1 I will be subtracting 1 value. That is the meaning of it, right? That is the meaning of it. And now my position will be moving to the next query. Okay, now again I will be checking the condition. If my I is at the first index, right? My I is at the first index, I will be checking if the sum value plus the difference array value here, which is 1, 0 plus 1, is it less than this value 2? If it is less than this value 2, means we have not yet reached to the actual value. If we reach to the actual value, then you can assume that the actual value has been reduced to 0, right? So 0 plus 1 is 1. We have not yet reached to the actual value. So the second query is saying that 0 to 1 updated by value 2. So 0 to 1 updated by value 2. What we will be doing? We will be updating this value. So 2 will be added and this becomes 3. And at index 1 plus 2, 2 will be subtracted. Okay, 2 will be subtracted. So this will become -2. Now you check it out. After doing this query, we will be moving to the next position. And if you check out now, the sum, initial sum was 0, and you have added 3 value at index 0, right? Now 0 plus 3 is 3. Now is this 3 less than this 2? No, it is not. That means after doing these two queries, we have definitely either reached to 2 or exceeded 2. That means we can always convert these 2 to 0, having seen the first two queries, right? And once we are done with that, we need to move forward. And before moving forward, whatever was the sum that is seen, we have to update this in the sum and move forward. So this is the moving sum that I was talking about, because this moving sum will give you the actual value at the index from the difference array. We had already seen this technique, that once the difference array is given, you can move from left to right, adding up the values all the time, and you will get the exact value in the actual array after the update. So that same technique I am applying here, but applying dynamically. Now once I am present at index 1, okay, now I will be checking, is this 3 plus 0 actually less than 0? No. So we do not need to do anything, we move forward. Now I will check if this 3 plus -2 is actually less than 3. No, 3 plus -2 is 1, right? So I still have 2 gap. 3 plus -2 is 1. I need to reach to 3 so that I can reduce this 3 to 0. So I will be processing this query. Now this query is from 3 to 4 with a value 2. So this is not for index 2, right? This is for a future query. But if I ignore this and move forward, then maybe the future items will not be converted to 0. So it's always optimal that if I see a future query, we will always process it. So from 3 to 4, I will be updating with the value 2, means I will be adding value 2 at 3. So this becomes 2, and at 4 plus 1, I will be subtracting with the value 2. And we are done with this query, we move forward. Now again, I will be checking, is this 3 plus -2 less than 3? Yes. So we have not yet converted this 3 to 0, let's say, or we have not reached to this 3 value, right? So what we have to do, again it is saying 0 to 1 with the value 1. 0 to 1 is an old query, right? So if your end of the query, like this is the start of the query and this is the end of the query, if the end of the query is actually less than the index that you are processing, then it is useless for us, because if you are present at index 2, then this means that everything to the left hand side was already reduced to 0. That is why we are present at index 2. So why would I want to touch anything to the left hand side? There is no meaning to it. So I will be moving to the next query simply. The next query is saying that 1, 2, 3 will be updated with the value 2. Now you see this. What index are you processing? Index 2, and it is saying update from 1 to 3 with 2. Why would I even bother about updating this one? Because it is to the left hand side, but 3 is on the right hand side, so there is a partial overlap over it. So I will only be updating the useful range. In this case, the range given is 1 to 3, and the useful range is only from 2 to 3, because 1 was already converted to 0, right? So I will be taking the max of the query start point, which is 1, comma, whatever is my current index I, which is 2. So my start point will be 2. So I will convert this query to 2 to 3 with the update 2. And if that is happening, then I will add 2 here, it becomes 0. And at 3 plus 1, I will subtract with the 2 value, and this will become minus 3. Okay. And I will go to the next query. Now at this point, check out this 3 plus 0. Is it less than 3? No. So that means having processed these 5 queries, definitely I would have converted this 3 to 0, or in the other way around, you say that I would have converted this 0 to at least 3. So our second query is done, or this query is done, so I can move forward. So if I can move forward, I will be reaching to this index 3, and before moving forward, I will be adding this difference value to this sum, and it will remain to be 3. Okay. Now at this point, you check, is this 3 plus 2 actually less than 1? No. So we are done. This means that we have already converted this 1 to 0, or starting from 0, we have at least reached to 1 or larger than 1. Okay. So no need to do anything for it. You move forward. But before moving forward, we have to add this value, and this becomes 5. Okay. Now we are at 4. And when we are at 4, we check 5 plus minus 3. Is it less than 4? Yes. 5 plus minus 3 is 2. I want to get a value at least 4, which is sum plus whatever is the difference array at I. So I have to process this in query. So in query 6, it is saying that I can update from 0 to 4 with the value 3. But what is my current index that I am processing? It is 4. Okay. So everything to the left have already been converted to 0. So it is not in my interest. So everything starting from 4 and going to the right is in my interest area. So I will be again updating the start and end value by maximum of whatever is the query start point, comma I, and that will make it 4, and the end point will remain to be 4. If the end point was actually less than the current index, then I will be skipping that query altogether, like I had skipped one of the queries in the beginning, right? I think query number 4 was actually skipped, right? So in this case, I will be starting at 4 and ending at 4. This means the 4 will be updated by a 3 value, and this becomes a 0. And at 4 plus 1, I will be subtracting a value 3. So this becomes minus 5. Now you check sum plus difference array at I, 5 plus 0. Is it less than 4? No. So that means I have actually converted this thing, right? I have actually successfully converted this 4 to 0, or you can say that from 0 I have reached to a value at least 4 or greater than 4. Okay, so this query was processed. We will be going to the next query, and we will be going to the next position. Now since we are done with all the array elements and we have not run out of queries, this means that whatever is the index of the query that we are looking at, we just return it as the result. So this was index 0, 1, 2, 3, 4, 5, 6. So 6 means we are already done with 6 queries. So the number of queries it took to actually convert this array to a 0 array. Or in another way, you can say that you can start from 0 and try to reach to this array, at least cover up each of these values, right? So both the techniques are the same. Either you convert the array to 0 or take a 0 array and convert it to the given array. The minimum number of steps required will be same. Okay, it is the same concept of if you start from 1 and you reach to 5 by adding plus 1 plus 1 plus 1 actually 4 times, or you go from 5 to 1 by subtracting minus 1 minus 1 minus 1 4 times, right? Something like that. So it is the same thing. So the number of steps taken are 6, and therefore the answer in this case will be 6. Now, if at any point of time, let's say that you had one extra item here. I mean, at any point of time, if your position never went to out of bound, okay, but you ran out of queries, then in such case we need to return -1, saying that the array could not be converted to a 0 array. That is the only thing. So this requires good understanding on difference array, and I have already made a video, so I think it will be extremely clear now. And the important workaround or the trick was to maintain a dynamic sum. Okay, the dynamic sum will always give you the actual array value at any given index. Now the time complexity will be n plus q, where the n is the array size and the q is the number of queries. From the constraints, we know that each of them will be around 10 to the power of 5. So you can say that if maximum both of them are 10 to the power 5, you can take them as n plus n, and that will make it as order of n. But I will write it as separately because they are not dependent. And the space complexity will be order of n because of the difference array. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this problem, we are given the nums array and the queries. So I will be taking the num size and the difference array of size n plus 1. So the sum will start from 0 and the position will start from 0, and I will be iterating for each of the items one by one. Okay. Now when I go for the first item, let's say the ith item, I will be checking if the sum plus difference at I is less than num size. This means that the number has not yet been converted to 0, or if you are starting from 0 and I want to reach to a number x, we have not yet reached to number x. So what I will do, I will check. If I have run out of all the queries, then I will return -1. Otherwise, if we are looking at a query, I will extract the start, end, and the value from the queries 0th item, first item, and the second item. Then once we have extracted the query, I will go to the next query position. You can also write it at the end. Okay. Now I will check if the end point of the query, that means the start and end range, if the end range is less than the current index, that means it is useless for us and I will be skipping this query. Okay. Otherwise, if it is useful, then I will be checking what is the useful range. The useful range will be max of start comma I, that you know, I already told you, and you add the value, and to n plus 1 you subtract the value. So this is the range update using the difference array, right? We will continue to process each query one after another until starting from a given 0 value until I have reached to at least a value x. I will continuously process it. If I have reached, then the sum plus difference at I will be greater than equals to the nums I, and at that point I have to break and actually go to the next index. If I was processing the ith item, I have to go to I plus 1th item, right? And when I go, I have to add the difference array value at I into the sum value so that I can get the actual item after having done q number of queries. That is the technique of the difference array. And once I am done with all the updates, if I never ran out of queries, then the position will be telling me about how many queries I have actually completed, and that will be the minimum number of queries to convert the given array into a 0 array. Okay. So I think the code is clear. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of this programming videos. See you guys in the next video. Thank you.